Hello everyone, my name is Madam Liana binti Truna. So I will teach you Learning Unit 9 Conic sections. Please get ready with your lecture notes, pen, paper to write down all the solutions and the other important notes that might be discussed during our lecture. What are some real-life applications of conic section? For example, there is an ellipse-shaped park in front of White House in Washington, and then when a tumbler of water is tilted, an elliptical surface of water is seen. Next application, water from a fountain takes a path of parabola to fall on the earth, and then the path traveled by objects thrown into air is parabolic. What is conic surface? A right circular conic surface is a surface generated by a rotating line anchored to a fixed point on the axis of rotation. Okay, from the illustration here, you can see that a surface generated by a rotating line anchored to a fixed point on the axis of the rotation. What is conic sections? A conic sections is a curve obtained from the intersection of a plane with a right circular conic surface. So there are three types of conic sections: ellipse, parabola, and hyperbola. But in our lesson, we only cover two types of parabola: ellipse that includes the circles, and parabola. The first conic section is circles. When the plane of intersection is perpendicular to the axis of rotation, the curve from the intersection takes the shape of a circle. Okay, you can refer to this illustration. So the plane of intersection is perpendicular to the axis of rotation. So it will take the shape of a circle. Next conic section is an ellipse. For the purpose of our discussion, we will call the angle between the rotating line generating the conic section and the axis of rotation as phi. When the plane of intersection is at angle between phi and 90 degree from the axis of rotation, the curve from the intersection takes the shape of an ellipse. So this is the illustration at angle between phi and 90 degrees from the axis of rotation. So we will get an ellipse shape. Next, parabola. When the plane of intersection is at angle phi from the axis of rotation, the curve from the intersection takes the shape of a parabola. So you can see the illustration right here. When the intersection is at angle phi from the axis of rotation, the curve from the intersection takes the shape of a parabola. Therefore, the parabola is angle phi. Okay, and for circle, angle of plane from the axis of rotation is perpendicular. And for an ellipse, angle between phi and 90 degrees. A circle is a closed plane curve generated by a point moving in such a way that its distance from a fixed point called center is constant. So the parameters for a circle is the set of points equidistant from a fixed point called center, C, with coordinate of the center, HK, a line segment determined by the center and any point on the circle is called radius R. Consider a circle having a radius of length R and a center C on a coordinate system. Okay. So to sketch a circle, we need y and x axis, and then center, HK, and the radius. Okay, so the radius is a line segment determined by the center and any point on the circle, R. From the definition, the distance of any point on a circle to the center is a constant. The arbitrary point P, xy, the center C, hk, the distance from P to C, therefore the formula for the distance R is x minus h squared plus y minus k squared and square root. So, squaring both sides of the equation, we obtain the standard form of the equation of a circle. So, to obtain the standard form of a circle, we need to square both sides. So, the equation of a circle in standard form, x minus h squared plus y minus k squared equal to r squared. And to convert the equation of a circle from standard form to general form, we need to expand the equation. So you need to expand the x minus h squared plus y minus k squared equal to r squared become the general form. So general form will be x squared plus y squared plus 2gx plus 2fy plus c equal to 0. So this is the general form of the equation of a circle. Let's try example 1. Find the equation of a circle with radius length of 5 and its center at 3, 4 in general form. So your answer must be in the general form. So given that the center formula for center is hk, so equal to 3, 4, h equal to 3 and k equal to 4. And then the standard form is x minus h squared plus y minus k squared equal to r squared. Okay, this one is the standard form. And then don't forget the radius is 5. So r equal to 5. Okay, and then substitute the value of h, k and r into the standard form. So x minus 3, h is equal to 3 squared plus y minus k is equal to 4, y minus 4 squared equal to, your r is equal to 5, so 5 squared. And then expand this standard form. Okay, so expand one by one, you will get x squared minus 6x plus 9 plus y squared minus 8y plus 16 equal to 25. Next, simplify your equation, become x squared plus y squared minus 6x minus 8y equal to 0. So the general form of a circle is equal to x squared plus y squared minus 6x minus 8y equal to 0.